This will be your second lesson involving inequalities. In the previous lesson, you learned how to solve or how to use solutions to inequalities and how to graph them. And so we're going to use that knowledge as well as new knowledge in this lesson. But the thing we're going to learn this time is how to solve inequalities using addition and subtraction. Now, everyone watching this video knows how to solve a basic equation using addition or subtraction, and so we're going to review that very quickly because of the fact that inequalities are going to be very, very similar in how we're going to approach them. So if we see an equation x minus 5 equals 12, then we all know that we simply add 5 to both sides to be able to undo that subtraction. Then we're left with x equals 17 there. Okay, and the same goes with addition. If we see addition, we know that we can simply subtract that 6 from both sides, so we can undo that. We're left with x equals 5. Now, with inequalities, if you're talking about addition and subtraction, those principles apply almost the exact same way. But let's quickly look at this property of inequality for addition. Okay, it says for every real number a, b, and c, if a is greater than b, then a plus c is greater than b plus c. And also the backwards works as well. The a minus b, then a plus c is less than b plus c. Let's take a couple of quick numbers to look at that and prove that. Okay, so let's say that we took 1, 2, and 3 just for example. Okay, um, obviously 2 is greater than 1, so we're looking at this one. Okay, um, so we'll go that route. Okay, then if that's the case, then we're also saying that if we said this was 3, okay, we're calling this 1 and this 2. Okay, then plugging it in right here, then we would have 2 plus 3 would be greater than 1 plus 3. I think we can all agree that 5 would be greater than 4. And that's just a simple explanation about how to plug that in. Um, but knowing those properties allows us to see a very simple fact that when we add to both sides of a fraction, then if we do the same thing, then that equals, or that inequality sign will remain the same. When adding, if you just simply add across both sides, it'll remain the same. It'll remain still a true statement no matter what you do there. Okay, so we're going to move on down, and we're actually going to take a look at some examples that go along with that. Okay, so example 1, it says solve p minus 4 is less than 1. Okay, just like we've solved with basic equations, then we want to add 4 to both sides, which if we add to both sides, then that would not change. So we're left with p is less than 5. Okay, now on your paper you probably have lines, but I'm going to draw me a number line right here. Okay, I'm going to make that 0. I have 1, 2, 3, 4, 5, and then I could have it going backwards as well. Okay, obviously the numbers that I need are on this side, so I'm just going to start there. Okay, now this is p is less than 5, so it's not actually including 5, so I'm just going to leave an open circle there. Okay, if it said less than or equal to, then I would enclose that circle, and then that way it would also include that one. But it says p is less than 5, so I need to darken. This probably be much easier on your paper, but we're going to darken going this way, okay, because we know that p is anything less than 5, and it'll be true. Okay, so next one we're going to take a look at checking that example, but we're going to move on for right now. Okay, we look at example 2, and it says solve 8 is less than or equal to d minus 2. Now a lot of you may be looking at that symbol and thinking, what is that? Well, this is the same thing as this, but a lot of times computers won't be able to write this down in this manner, so this is just like a little extended way to write that, less than or equal to. Same thing as this, okay? So since you know that, I'm going to get that out of the way, but you need to have written that down, that that's the same thing, okay? Now, if we're going to work this, we need 8 is less than or equal to d minus 2. So we would add 2 to both sides, just like an equation. Okay, so I'm left with 10 is less than d, okay? Less than or equal to. So I'm going to put my 0 right here so that I can count off and get to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just give me a couple extras. Okay. All right. And it says less than or equal to, so I'm going to fill that in. Okay. Now it says 10 is less than or equal to D. Okay. So that means that D has got to be actually greater than. And we can kind of read this backwards. We can say D is greater than 10. So that means we need to go in this direction for this to be a true statement. Okay, so like 12 would work. So actually, let's take a look at that. It says check your solution. So the way that you would check your solution is you would take something from this side arrow, and I mentioned 12. So let's check 12. Okay, let's take 12 and let's put it in for D, and let's see if we have a true statement. Okay, so let's put 12 in right there, minus 2. All I did was just plug it into the original inequality. Okay, so 10 minus 2 is 10. Now, you have to ask yourself the question, is 8 less than or equal to 10? I believe it is. It is less than, so therefore it works. Now, if we use 10 itself, we would plug it in. We get 10 minus 2 is 8, and it would be 8 is less than or equal to 8. And since or equal to is acceptable, then it would work as well. So that's a good way to check your solution, just to plug in one or two solutions or possible solutions and just see if they work. That's the nice thing about inequalities is not just one simple answer. Okay. Well, let's look at the contrary. Obviously, we said we could add to both sides and it not change that sign. Okay, but here it's telling us that for every real number, A, B, or C, if you said A was bigger than B, then if you or subtracted C from A and from B, then it would still be greater than, okay? So same thing for the other sign as well. So we're going to keep on scrolling down. We're going to do one more example, and this time we're going to be using subtraction. And I think we've all got the concept by now because it's just like an equation. So we're going to take this C plus 4 is greater than 7, and we're going to solve for C. Okay, so the way we do that is we subtract 4 from both sides. So that's gone. Okay, we got C is greater than 3. See, that sign did not change. Okay, later in the next lesson, I believe you're going to learn about multiplication and division, and that's going to be a different story. But for right now, for addition and subtraction, you don't have to worry about that thing flipping around or anything else. So it's a very simple process now. Okay, so we have A is greater than 3. Okay, I'm going to make myself a number line. Okay, we got a couple of them going back, some going forward. Okay, so 3 is here. Okay, it says it is greater than. It doesn't say or equal to, so I'm going to leave an open circle. All right, and it says greater than, so obviously anything greater than 3 would be on this side, so I need my arrow pointing this way. Okay, all right, so basically we have found that anything greater than 3 would work as a solution for C. So let's check that real quick. How about 5? Okay, if we said 5 plus 4 is greater than 7, then yes, 9 is greater than 7. Now, what if we chose something less than 3? How about 2? 2 plus 4 greater than 7. That doesn't make sense. That's not actually less than or greater than 7, so therefore it wouldn't work. So that proves this was the right thing to use. Okay, so ask your teacher some questions if you have some, but it's very simple to equations, so please have confidence in that knowledge that you already have. Thanks.